P-values explained simply can make statistics, data science, and research feel a lot less confusing. Welcome to QuickBytes Education. Today's QuickByte is all about p-values, explained simply, quickly, and clearly. Let's get started. So, what is a p-value? A p-value is a number that helps us understand how surprising our results are. More specifically, it helps answer this question. If there were no real effect, how likely would we be to see results like this just by chance? That may sound a little tricky, so let's make it simple. Imagine you flip a coin 10 times. If the coin is fair, you expect about 5 heads and 5 tails. But what if you get 10 heads in a row? That would feel surprising, right? A p-value helps measure how surprising a result is under the assumption that nothing unusual is happening. In statistics, that nothing unusual is happening idea is called the null hypothesis. The null hypothesis is the starting assumption. It usually says there is no real difference, no real effect, or no real relationship. For example, a new study method does not improve test scores. A new medicine does not work better than the old one. A new website design does not increase clicks. A p-value helps us decide whether the data gives us enough reason to question that starting assumption. Let's use a simple example. Imagine a school wants to know if a new study app helps students score higher on tests. The null hypothesis would be, the study app does not make a real difference. Students take a test, use the app, and then take another test later. Now the scores improve. Great, right? But here is the big question. Did the app actually help? Or could the improvement have happened by random chance? That is where the p-value comes in. A small p-value means the results would be unlikely if the app truly had no effect. So, a small p-value can be evidence that something real may be happening. Here is a simple way to think about it. A small p-value means the result is more surprising if the null hypothesis is true. A large p-value means the result is not very surprising if the null hypothesis is true. For example, a p-value of 0.03 means there is about a 3% chance of seeing results like this, or more extreme, if the null hypothesis were true. That does not automatically prove the app worked, but it does suggest the result may be worth paying attention to. Now let's talk about statistical significance. In many beginner statistics lessons, you will hear about the 0.05 cutoff. If a p-value is less than 0.05, people often call the result statistically significant. That means the result is considered unlikely enough under the null hypothesis that researchers may reject the null hypothesis. But remember, 0.05 is not a magic number. It is a common guideline. Different fields, studies, or situations may use different cutoffs. And statistical significance does not always mean something is important in real life. Here is one of the biggest mistakes beginners make. A p-value does not tell you the chance that your hypothesis is true. It also does not prove that something definitely works. A p-value only tells you how surprising the data would be if the null hypothesis were true. That is why p-values need to be interpreted carefully. For example, a result can be statistically significant but still have a tiny real-world effect. Maybe a study app improves scores by only 1 point. That might be statistically significant with enough data, but it may not be very meaningful in practice. So always ask, is the result statistically significant? And is the result practically important? Those are two different questions. So why do p-values matter in data science, data analytics, and research? Because they help us make decisions based on evidence instead of guessing. A data scientist might use p-values to compare two marketing campaigns. A researcher might use p-values to test whether a treatment has an effect. A business analyst might use p-values to see if a change in sales is meaningful or just random noise. P-values are often used in hypothesis testing, experiments, A/B testing, medical studies, psychology, business research, and machine learning evaluation. They help us decide whether patterns in data are likely to be meaningful or whether they may have happened by chance. Here is a simple memory trick. Think of the P in p-value as standing for probability of surprise. That is not the official definition, but it can help beginners remember the idea. A low p-value means, wow, this result would be pretty surprising if nothing real was going on. A high p-value means, this result is not that surprising, so we may not have strong evidence of a real effect. So let's recap. A p-value helps measure how surprising your data is under the null hypothesis. The null hypothesis usually says there is no real effect, no real difference, or no real relationship. A small p-value means the result is less likely to happen by random chance if the null hypothesis is true. A large p-value means the result is not very surprising under the null hypothesis. A p-value below 0.05 is often called statistically significant, but it does not automatically prove something is true. And p-values should always be interpreted with context, sample size, effect size, and real-world importance. In one sentence, a p-value helps us decide whether a result in data looks meaningful or whether it could reasonably be explained by chance. Like, subscribe, and keep building your knowledge with QuickBytes Education, one QuickByte at a time.